Okay, this is day 2 of the discriminant, and the rest of the page I think you'll be fine on. The first 6, you should be able to look at the graph and see how many solutions it has. If not, you can always use the equation and find the discriminant. If it's positive, it'll have 2 real solutions. If it's 0, it'll have 1 real solution, and if it's negative, it will have 0 real solutions. So I do want you to work on 1 through 15, and I'm going to do 16 and 17 with you because I think they jump into this. The modeling, we have not gone over that yet, so we're just going to do those together. Notice it tells you that they are launching a rocket straight up from the ground. Whenever something says that it's leaving the ground, then that means that C will be 0 because it doesn't have any initial height. Like, if it's on the ground, then it's 0 feet off the ground. And it says an initial velocity of 60 feet per second. You have a camera focused on a point 40 feet above the launch site. How many chances will you have to photograph the rocket? Well, they've given us an equation up here. So if we read this, we'll have a much better chance of solving. So the formula or the equation that models this rocket is -16, and I'm just going to say x squared because I feel like t squared, it looks like a plus, and I'm just not going to do it. Okay, -16 plus the velocity, which in this case is 60x. The reason they use t is because they're talking about time. What you do is you plug in a value for how many seconds it's been since the rocket left the ground. And let's say it's been 3 seconds. If you plug a 3 in for t, then you can see how far the rocket is in the air. So they use t for time, and we could use t too, it doesn't mean anything. But I feel like it looks like a plus, so I'm going to use an x. But know that this x means time, just like t would. And it says C is the initial height, well, let me finish it, where h is the approximate height in feet of the object that is propelled upward. T is the time in motion in seconds, V is the initial upward velocity in feet per second, and C is the initial height in feet. Well, what we know is that it got launched from the ground, which is when C is 0. So C is going to be 0. We don't really need to write it, but we can. And now we know what our A, B, and C is. So A would be -16, B would be 60, and C would be 0. The fact that C is 0 makes our job a lot easier. Because watch what happens. B squared minus 4AC. Well, B is 60, so we're going to have 60 in here. 60 squared. And then A is -16 and C is 0. Well, anytime you multiply by 0, anything times 0 is 0. 1,000,000 times 0 is 0. So all of this is going to go to 0. Because when you multiply anything times 0, it becomes 0. So what really happens is you just get 60 squared. Well, which is 3,600, by the way, but we don't really even care what it is. We're only looking, is it positive, is it negative, or is it 0? And it's a positive number. So this would be 2 real solutions. But it gets more complicated than that, because you really can't use the discriminant 100% with these types of problems. You actually have to graph the equation and see what's happening. So we don't need a plus 0. But this is the equation right here. So we're going to graph this. And this is it after it's graphed. Notice that it's -16 x squared plus 60x. And it gives the shape of the parabola. And, it doesn't really exist in the negatives here. But the graphing calculator is going to graph it as if it goes on forever. But this is the ground, so let's color it green. This is the rocket's ground, and the rocket is being launched at ground level, and it goes up and follows this pattern. Well, she's got her camera. I put an equation here y equals 40. Notice there's a blue line right through here. This is where her camera is sitting. So imagine that there's a camera right here, and it's taking pictures. Well, it has a chance right here to take a picture, and it's got another chance here to take a picture. So it has two chances. So the answer is still 2. We said it was 2 with the discriminant, and we proved it was 2 with the modeling of the equation. But the next one's a little bit difficult, or a little bit different. So let's read the next one. It says, Juliet was standing on a balcony with her arms outstretched 13 feet above the ground. Romeo, standing on the ground below, tosses a rose up to her. It leaves his hand 4 feet above the ground with a speed of 20 feet per second. How many chances will Juliet have to catch the rose? So let's write the equation first. So we know it's going to be in this format. So negative 16x squared. And then the velocity was 20 feet per second. So plus 20x. And the initial height was 4 feet above the ground. So plus 4. So notice the only thing we had to fill in were the b and the c. And the b in this example, of course, is the velocity of the object being thrown. And c is the height that it started from. Like, before you ever launched it in the air, how far from the ground was it? And it was 4 feet from the ground. So let's model this. And notice that right here, it starts at 4 feet. Like, the parabola actually begins at 4 feet. So this would be like Romeo is standing right here, and his arm is 4 feet from the ground. And he's ready to throw the rose up to her. So this doesn't exist in real life. It just starts at 4 feet. But Juliet is up here, and she's standing on a balcony 13 feet from the ground. The rose gets tossed in the air, and then it falls back down. It never gets close to her. She has 0 chances to catch that rose. But you can't tell that from the equation. I think it's very difficult to see that without graphing the equation. And when you do the discriminant, it does cross over the x-axis twice. So when you do the discriminant, it looks like it's going to have 2 real solutions. But to answer the question, it would be a 0, because Juliet has no chance of catching that rose. It's too far away from her. The highest that the rose would get looks like it's maybe 10.25 foot. I mean, if I'm looking here, looks like it's probably about 10.25. So I hope that makes sense. Those 2 questions are definitely different than the other questions on the paper. If you need help with the other questions, make sure you raise your hand, and I do expect you to do the whole page.